sklearnutilscheckscalar. Description. The checkscalar function in scikit-learn sklearn is a utility function used to validate that a given input is indeed a scalar value. It plays a crucial role in ensuring data integrity and consistency within machine learning pipelines, especially when dealing with model parameters or data transformations. Inputs. X, the input value to be checked. This can be any Python object. D, type, the expected data type of the scalar. If not provided, it defaults to none, meaning any data type is accepted. You can specify specific data types like int, float, str, etc. Target type specifies the expected type of the input. It can be numeric for numerical values, str for strings, or bool for booleans. Float kind optional, the float kind, such as float 64 or float 32, to be checked. If not specified, the function will accept any floating point type. Int kind optional, the integer kind, such as int 64 or int 32, to be checked. If not specified, the function will accept any integer type. Outputs. Returns the input value x if it passes the validation checks. Raises a value error if the input is not a scalar or if it fails to meet the specified data type or target type requirements. Steps. Type checking. The function first checks the type of the input value x. If the input is not a scalar, i.e., it's a list, tuple, dictionary, or another complex object, it raises a value error. Data type checking. If a D type is provided, the function verifies if the input's data type matches the specified D type. If not, it raises a value error. Target type checking. If a target type is provided, the function ensures that the input's type corresponds to the specified target type, e.g., numeric, str, or bool. If not, it raises a value error. Floating point and integer type checking. If float kind or int kind is provided, the function checks if the input is of the specified floating point or integer kind, respectively. If not, it raises a value error. Metrics. Data validation. The primary metric is the successful validation of the input as a scalar meeting the specified criteria. A successful validation means that the input is a scalar and meets the data type, target type, and if applicable floating point or integer kind requirements. Visualization plots. Data type distribution. You can visualize the data type distribution of the input values to identify potential inconsistencies or unexpected types. This can help in understanding the nature of your data and potentially debug issues related to data type mismatch. Fine-tune parameters. D-type. The D-type parameter allows you to specify the expected data type of the input scalar, enforcing stricter data validation. Target type. The target type parameter enables you to define the expected type of the input, further refining the validation process. Float kind, int kind. The float kind and int kind parameters provide fine-grained control over the acceptable floating point and integer types, respectively. Uncertainty methods. Type inference. The checkscalar function uses type inference to determine the type of the input. However, this inference can sometimes be ambiguous or inaccurate, especially for complex objects. If you have doubts about the accuracy of type inference, it's essential to provide explicit D-type or target type parameters. Challenges and fixes. Challenge 1. Incorrect type inference. Sample use case that resulted in challenge 1. You might have a variable containing a string that represents a number, like 1.2. Type inference might consider this as a string, but you might intend it to be a floating point number. Fixes to challenge 1. You can use the D-type parameter to explicitly specify the expected data type. ensuring that the string is interpreted as a float. For example, check scalar, D-type float. Challenge 2 unexpected input. Sample use case that resulted in challenge 2. Your code might receive a list, tuple, or other non-scalar objects as input instead of a single scalar value. Fixes to challenge 2. Review your code carefully to identify the source of the non-scalar input. Ensure that the data you are passing to checkscalar is indeed a scalar value. If necessary, modify your code to handle and convert the input to a scalar if it's a non-scalar object.